Hello students, I am Nilanjana Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12. This is my website www.nsonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. Okay. Now our today's topic is compound interest and geometric sequence. We are learning about financial mathematics and financial mathematics using the sequences. Okay. So today's topic is compound interest. And we have all solved compound interest questions, but we will be knowing how is the compound interest formula that we know is related to the geometric sequence. And we will be using the formula which is showing us the relation between the compound interest and the geometric sequence for the computation of the amount and the compound interest or the rate or time, whatever it may be. We will be using this geometric sequence formula. Okay. So when money is deposited in a bank, it will usually earn compound interest. That is what usually every bank offers. Okay. So suppose $P is deposited in a bank where the rate of compound interest paid per annum, this is important. We will be seeing how this per annum thing, if changed to half yearly or quarterly, how the formula gets changed or modified. But for the timing, let us first of all assume that the compound interest is getting paid per annum and the rate of compound interest paid per annum is R% for n years. Okay. Therefore, amount in the bank at the starting of the n years is represented by A0. This is equal to $P, or the principal is the $P. Okay. So, A1 is the amount after 1 year. This is at the starting, beginning of the 1 year is A0, and amount in the bank after 1 year or at the beginning of the second year is $P will be there. This was the initial investment. And then what is the interest earned? It is R% of P. And if we take P as a common factor, it becomes P is there outside the parenthesis and 1 from this term and R over 100 from this term, second term. Okay. Now this is the amount after 1 year or at the beginning of the second year. Okay. Now coming to A2. What is A2? This is amount after 2 years. Okay. Or at the beginning of the third year. So, for A2, what is the original amount? This is this. So, I am writing this. Plus, what is the interest earned? This is R% of this original amount. So, R over 100 times this part. Now, I am taking this whole thing as the common factor between the two terms. So, it is 1 plus R over 100 times P. This is the common factor. And from the first term, we have a single 1. And from the second term, we have R over 100. Okay. So we are having 1 plus r over 100 over here and 1 plus r over 100 over here as well. So the expression becomes equal to 1 plus r over 100 whole square times p, or p times 1 plus 100 r over 100 whole square. This is the amount in the bank after 2 years or at the beginning of the 3rd year. Okay. So proceeding in the same manner, we are in a position to get the expression for the amount in the bank after n years. That is AN. When it was after 1 year, it was A1. When it was after 2 years, it was A2. So after n years is AN, or at the beginning of the n plus 1th year is 1 plus r over 100 to the power of n times p dollars. Okay. Now you can see that the initial was $P. Then if we take this to be the first term, what is the second term? It is 1 plus r over 100 times p. So the common ratio is 1 plus r over 100 between the first and the second terms. Between A1 and A2, that is the second and the third terms, it is again a common ratio of 1 plus r over 100. So we see that the terms are following a geometric sequence pattern. Okay. They are having a common ratio of 1 plus r over 100 between them. This is the common ratio. And what is the power? Power, if you think this is the amount after n years, you may get confused. But if you think this amount to be at the beginning of the n plus 1th year, so n plus 1 minus 1 will be giving us n. If you read this amount as the amount in the bank available at the beginning of the n plus 1th year, then it just follows the geometric sequence pattern. Okay. Or else you have to remember that we are not starting from A1, we are starting from A0, and that is why we are having this discrepancy. Okay. But if you just consider this amount to be the amount at the beginning of the n plus 1th year, it exactly follows the general term formula for any geometric sequence. N plus 1 minus 1 is equal to n, where the first term is p and the common ratio is 1 plus r over 100. Okay. So now that we know about the formula, let us try to do few questions. Based on this formula, we will be finding the we will be finding the amount and the compound interest using this formula. So 2000 euros is invested. This is our initial investment, that is A0 or $P, not dollar, P euros, is invested for 4 years. That means n is equal to 4 at 2.8% per annum. That is r equal to 2.8%. Per annum interest compounded annually. That means the compound interest calculation is done only once in one whole year. And we will be seeing how does the formula get modified when the calculation, compound interest calculation is done half yearly or quarterly or monthly. Okay. But for this very question, we are seeing that the compound interest is calculated only once in one whole year. That is compounded annually. Okay. And the first part says what will it amount to at the end of this period. This period means 4 years. And subpart B is how much interest, that means compound interest, has been earned. So let us start with our answer. So, we can write AN, let me write the formula first of all. AN is equal to A0 and 1 plus R over 100 to the power of N. Okay. So, that is, now N value is 4. So, we write A4 is equal to A0 or P is equal to 2000. And 1 plus 2.8 over 100 to the power of 4. Okay. Now we have to bring in the calculator. So it will be 2000 multiplied by 1 plus 2.8 divided by 100 whole to the power of 4. It is 2233.6 I may take. Okay, 2233.6. So this is equal to, here is 2233.6. This is the subpart E. Subpart A's answer is 2233.6 euros. So let me write over here 2233.6 euros is the amount after 4 years. Okay. And how much interest has been earned? So, interest will be the final amount minus the initial amount. That is, in this case, A4 minus A0, which is equal to, A4 is 2233.6 minus 2000 equal to 233.6 euros. Okay. So this is the compound interest that has been earned during these 4 years. Okay. So this is our answer. Okay. So students, this brings us to the end of this session. We will be doing some more questions on compound interest using this geometric sequence formula in our next session. And we will be knowing how is the formula getting modified when we have to find the compound interest or the amount which is getting calculated half yearly or quarterly. Okay. Or what is the initial investment. We will be learning all of those stuff in our coming video. So thank you for watching this video till the end. We will be meeting very soon. Please give this video a like in case you have found it useful. Please subscribe to my YouTube channel. It will be motivating me to make more math videos which may be helping you in your math classes. Do not forget to press the bell icon. You will be getting notified as soon as I publish a new video. So bye for now.